Before anyone gets in, I'm going to go ahead and start going through some of the topics. I'm recording this so that you can access it later. What I'm doing is I'm actually picking the topics that the largest number of students are ready to learn based in the percentages in ALEKS. And so the first one I'm going to go over is evaluating a piecewise defined function. So that is this topic right here. So it's saying, suppose that the function h is defined for all real numbers as follows. H of x equals -1/2 x minus 1 if x is not equal to -2. And h of x is equal to -1 if x is equal to -2. So essentially it's defined the domain of the function, or splits the domain of the function. So for all numbers that aren't -2, we use that first part of the function to evaluate. And then if x is equal to -2, then it's equal to the second, or evaluated with the second part. So looking at the three x values they want us to evaluate at, we have x equals -5, which is going to use that first part of the piecewise function. So we take -1/2 x, we're going to replace with -5 minus 1. Remember, any whole number I can rewrite as a fraction by putting it over the number 1. So that'd be -5 over 1. So then I multiply my fraction -1/2 times my fraction -5 over 1, which gives me -1 times -5, which is +5, over 2 times 1, which is 2. So that's 5/2 minus 1. 1 I can rewrite as 2 over 2. That might help get a common denominator. And so 5/2 minus 2/2 is equal to 3/2. So the answer for this first one is going to be 3/2. Now for when h is equal to -2, that is when you use this the second part of the function, because x is equal to -2, we define our piecewise function is defined to be -1. So I don't actually have to solve anything there. The answer to that is just -1. And then for x is equal to 5, it's almost the same process as the first one. I'm going to do -1/2 times 5 over 1 minus 1. So then I get -5/2 minus 1, which I can rewrite 1 as 2 over 2. And so I get -7/2. So -7/2. And it's okay that the negation is outside of the fraction. You'll see in one of the videos I posted in Blackboard that that's like a normal thing that occurs. So let's go ahead and check our result. All right, let's do another one. On this one, we have here that the function g is defined for all real numbers as follows. G of x equals -1 if x is less than -2. G of x is equal to negative, parentheses, x plus 1, close parentheses squared, plus 1 if x is between -2 and less than negative. So we would say -2 is less than or equal to x, which is less than 1. So be careful when you see this based on the signs. Notice that if I have an x value of -2, it would be the second part of the piecewise function. If I have an x value that's 1 or greater, it's going to use the last third part, the 1/4 x plus 2. So you have to be very careful, especially for those border points, those border x values. Make sure you're applying it and evaluating it at the correct part of the function. So anyway, we're given 3 x values. We're evaluating g of 0. X equals 0. It lives in the domain that is defined as -2 is less than or equal to x, which is less than 1. So we would substitute in 0 for our function. What that looks like, I'm going to type in the chat. It's going to be -0 plus 1 squared plus 1. Okay, so I get 1 squared, which is 1, negated, which would make it negative 1, because that negation's on the outside. So I have to apply the exponent first, and then it gets negated. So I end up getting negative 1 plus 1. Negative 1 plus 1 is equal to 0. For the second one, 1. 1 is at one of those barrier points. So I have to figure out, am I going to use that second definition of the negative x plus 1 squared plus 1, or do I use the 1/4 x plus 2? And so if I think about this, I have to look at the sign. It says if x is greater than or equal to 1, we use that last one. And so therefore, I'm going to use the 1/4 times our x value, which is 1. So 1/4 times 1 is 1/4. 2 plus 1/4 is 2 and 1/4, which is the same thing as 9/4. It's going to make me define it as an imperfection, which is fine. 9/4. I'm going to write that down just to verify. 1/4, 2 and 1/4. Yes, 9/4. I like to double check. You should always be double checking as well. For g of 3, 3 in the domain is evaluated where x is greater than or equal to 1, because 3 is greater than or equal to 1. So we end up getting 1/4 times 3 plus 2. That's going to be equal to 2 and 3/4, because 1/4 times 3 is equal to 3/4. And so you add that to 2 and you get 2 and 3/4, which is the same thing as 11/4. Go ahead and check our answer, and that is correct. So again, on this one, what you're doing is you're substituting in your values of x into the correct part of the defined piecewise function. So you have to be very careful about which part of the defined function you're substituting the values into based on the definition So, sorry, I got distracted.